Now, how do we actually get our NFT to show this stuff, this SVG NFT? Well, we're going to pass the SVG text in here, right? But what we could do instead of that is we could just pass in the encoded image already, right? We could just encode these images ourselves. So if I, for example, and we kind of already did, right? If we open up our README, I'm just going to delete everything. Let's do happy SVG. What we can do is we could pull this up, clear. We could do base 64-I, happy SVG, copy this, hit enter. We need to prepend with data, image / SVG plus XML, semicolon, base 64, comma, paste that in. If I copy this, I can just double check by pasting it in the browser. Yep, okay, that looks good. So that's gonna be our happy SVG. We can do the same thing with our sad SVG, base 64-I, sad SVG. Do the same thing. We're gonna copy this output it gave us, which is a lot bigger. Paste it in here, and we're just gonna prepend it with this as well. Boom, copy the whole thing, paste it in here, and cool. We have a sad SVG as well. Nice. So we have those already. So why don't, instead of us passing in the text of the SVG and the NFT, instead of passing in these, we just pass in the already encoded version, right? It'll save us a step. We can base 64 encode these on chain, and I'll show you how to do that in a second, but it'll probably save us some gas if they're already encoded. So instead, let's say sad SVG image URI, happy SVG image URI. Let's have these be the imports instead. And what's important that it's just the image URI we're passing. We're not passing the token URI, right? Why not? Because, well, the token URI, if we go back to our pug test, the token URI is going to look like this, where it's not the actual image, it's this JSON object. It's this metadata object. The actual image URI is here. The actual token URI is here. Okay, so this is the token URI. This is the image URI. Token URI, image URI. This is what the NFT looks like. This describes everything about the NFT. This is the token URI. So this, in our README, this giant thing, well, or this thing is the image URI. It is not the token URI, it's the image URI. So back in our mood NFT, we're getting that image URI. So let's make this more specific. Let's call it sad SVG image URI, happy SV image URI. So sad, happy. So we're going to pass this already encoded data to our NFT. Nice. So how do we actually store this object on chain? Well, we can actually encode JSON objects the same way we encoded SVGs using that base 64 stuff. And we can actually do it on chain using OpenZeppelin's base 64 package. OpenZeppelin has some utilities, where one of them is a base 64. Base 64 utils allows you to transform bytes 32 data into a base 64 string representation. So that's what we're going to do now. We're first going to make our metadata JSON object, and then we're going to use OpenZeppelin to convert this JSON object into a JSON token URI. So let's learn how to do that. So we already have OpenZeppelin installed. Oh my goodness, I'm such a noob. I'm so sorry. Named import from, here we go. Okay, cool. Now let's go ahead and let's import. We're going to import this base 64 file from at OpenZeppelin. We've already got the remappings and everything, contracts /utils /base 64.sol. It's in the package, I promise. And we can use this base 64 thing to actually encode stuff. So let's scroll down to our token URI. And let's just write out this as if it were just a giant string, right? Let's just create this metadata object. So first, boom, name. Let's get rid of that. What's our name going to be? And let's make this just a giant string. So let's say string memory token metadata equals name. And we're going to need to combine this string with the name of our NFT project here. Do a little comma, boom, boom. We could do this. Oh, and then a little comma here. But we could do abi.encode packed to concatenate this whole string together. Or we learned another way to combine strings. We can do string.concat like this. Boom. So we can concatenate this, and what this will print out is name mood NFT, right? Because we're combining the name and the mood NFT. So that looks pretty good. However, we need the rest of the stuff. So we need name, description, image, and then attributes, right? So we got a name in here. Let's keep going. What else do we need? Well, we should do, so we shouldn't finish it here. Let's even just delete this. We should do a comma, space, and I'm going to toggle word wrap again, just so that it's on. Description, and then we can just add whatever we want in here. Let's say an NFT that reflects the owner's mood. Great. We'll do a comma, attributes. Now our attributes are going to be in this list style here. So we're going to say attributes, little list here, another bracket. We're going to say trait type, say just kind of a silly attribute here, moodiness, value 100, and then close off the list. Okay, cool. Looks good. Image. And now this is finally where we put our image URI, right? Image URI, and then we'll say comma, and then we'll finally close off the text here. So this is going to be the metadata of our token. Since we're parameterizing it a little bit, it will look like this once the two of these populate, right? Our image URI, though, we need to derive based off of the mood of each person, which we haven't defined yet. So we should make a little mapping of like token ID to mood. So we can do that up here. We'll say mapping uint256 to mood. And let's even create an enum mood of happy and sad. And this way, if we wanted to add more moods later, we could add more moods later. So mood, this will be a private s_token ID to mood. And when an NFT gets minted, let's just default them. We'll say the mood is going to be of s token counters will be mood.happy. So we're going to default them to being happy. So to get the image URI up at the top here, we could do a little if statement. We could say if s_token ID to mood of the token ID equals mood.happy. Let's do this. Let's create this blank string memory image URI. We'll say image URI equals s_happy SVG image URI. And we'll say else image URI equals s_sad image URI. So now we have a way to add the image, whether their person is happy or sad, right to the token metadata here. Of course, we're probably going to want a way to flip our mood, and we will add that later. So this is looking pretty good, but this is just the token metadata, right? This isn't the whole thing. This isn't the whole shebang, because this is just a string. We need this token URI to return a string that looks like this, a string we can post in the browser. This string, you can't really post this in the browser URL, right? So what we need to do is with this token metadata string, we do string.concat, or string.concat is nice, but we actually need to convert it to bytes. And we need to do abi.encode packed like this, and it needs to not be a string. abi.encode packed, and we need to make it a bytes like this. We actually could do string.concat, but I'm just do abi.encode packed because we need to convert this to bytes in order to use the OpenZeppelin base64 encoder. If we look at the OpenZeppelin base64, it says it allows you to transform bytes data into strings. And you can see actually in the examples here of the OpenZeppelin docs, it also uses an NFT as its example. So we need to convert abi.encode packed to bytes, and then we can do base64.encode this whole thing like that. And now that we're base64 encoding it, that's equivalent to us getting this giant piece when we did it from the command line. We still need this beginning piece. So we can get that by just concatenating this beginning part. So this is where we're going to need this beginning part. Now, since this is a JSON object, it's not a data image SVG XML. We're going to need to create a function. Let's create a function called underscore base URI. It's going to be internal here override, because the ERC 721 also has a base URI function that we're just going to override. It's going to returns string memory. If we're working with JSON objects, we'll say return data application slash JSON semicolon base 64, like this. So this is going to be the base URI of our metadata. Return. We're going to concatenate this with this by doing abi.encode packed or string.concatenate abi.encode packed like this. And then we're going to wrap this whole thing up as a string like this and then return it. Okay, that's kind of a big thing here. So we'd still want to be able to flip the mood and everything, but let's write a test just to see if this is working correct. First, we created this string. We concatenated it together using abi.encode packed. We turned it into a bytes object. Then we encoded that bytes object. We combined that with a base URL, and then we turn that whole thing into a string and return that. So let's do a quick sanity test here. So we're going to create a new file, mood NFT test.t.sol. And we're not even going to write a deploy script yet. We're going to write a deploy script, but we're going to skip it for now. And we're going to just make sure that this token URI function is working correctly, right? It should default to the happy SVG. So we'll do SPDX, license identifier, pragma solidity, caret 0.8.18, contract, mood, NFT test is test. Import test from forge std test.sol function setup public. And we're going to, of course, need to import our mood NFT from /src/mood nft.sol. We'll say mood NFT up at the top. And then we'll even just deploy this ourselves. We'll say mood NFT equals new mood NFT. And our mood NFT takes what? Takes the sad SVG URI and the happy SVG URI. So we could do string public constant happy SVG URI equals. We'll go back to our README because we already created these. And we'll copy this, put a little string here like that. Then we'll do the same thing. String public constant sad SVG URI equals. Same thing. We already created this one. Gonna copy this, paste it in here. Semicolon. So what goes first, the happy or the sad? Sad goes first. Okay, why did we put the sad first? Sad first, happy SVG URI. Okay, cool. So now we have our mood NFT. Now we'll do function view or function test view token URI like this. We make this a public view, or no, just public actually. And what we'll do is we'll do mood NFT dot mint NFT. So now we should have, look at our mint function. We should now have a token URI, a token 0. And then we could just do a console.log mood NFT dot token URI of 0, right? And of course, we're going to need to import console from test.sol. So we can do that console.log. Okay, cool. We'll pull this up, go down to the Foundry NFT F23 directory, PWD. Cool, we're in the right one. Forge test-m-vv, so we can see the console.logs. Transfer to non-ERC 721 receiver implementer. So this is already an interesting error that we're getting. So when we call mint NFT in our test, we're actually minting it to this test contract, right? And this test contract doesn't have a receive function, and OpenZeppelin baked in some code so that people wouldn't accidentally send NFTs to contracts that can't transfer them or do anything with them. So instead, we're just going to do vm.prank. We'll create a user. We'll do address user equals make ADR user. We'll prank the user so that it'll go to a user. It'll go to an address as opposed to a contract. So we can actually see this error. We go to the ERC 721 contract. We look for that error, and we see on the safe transfer from, there's this check on ERC 721 received. And if we click into this function, it does a whole bunch of checks in here. Basically checks to see if there's a function selector called on ERC 721 received, right? And again, the reason for this is to make sure that if you're sending this NFT to a contract address, it's expecting to get an NFT so it could possibly remove them, right? Or transfer them or whatever, right? So for now, we'll just prank a user. We'll rerun our test, pull this up, and okay, we get this as our log. So this is going to be our token URI. We can see the data application / JSON base 64, and we're assuming this is the encoded JSON object. So if we grab this, paste it into our browser now, okay, that looks pretty good. That looks like a JSON object. Then if we grab this, paste this into our browser, we see the happy SVG NFT. So this is how we can know that our token URI function is actually working correctly, right? Because we can see that it's printed out. And what we could do if we wanted to is we could start up our Anvil chain, right? Make Anvil and deploy to Anvil, then mint an NFT on Anvil, switch over to Anvil and try to see it in our MetaMask as well. So if you want to do that, highly recommend you give that a try.